First of all, I would like to start about the final gala. When I was last week, it was an event connected with the Mother and Child Institute. It was a startup contest that showed the possibilities of what kind of solutions, technologies we can apply in the hospital area in Poland. So the contest was focused on the startups. There was hospitals which want to apply new solutions for them, as well as the public institution like our government, as well as the institution connected with the financing public health. And what is interesting, 21 countries show the solution for this contest, and it was selected 10 startups. One was from Spain, and what is interesting, the main winner, Promet, it is a solution that can support the surgery and operating block. So the next one, I have selected the 5 promising startups which I saw. So the first of all, there is the winner, Promet, and this company optimizes operating theater. It can save about 75 minutes daily. They can increase the revenue from the surgery and generate savings for the hospital. The second one is Nursi. This is a startup that uses AI vision to monitor patients. So it is interesting when we have medical staff and we can see what's going on with the patients. So this system can monitor the patient and what is going on during the in the hospital. Smart Pharma Optimizer is a solution that can help to analyze the drug decomposition. Dizure App is an application that can automate shift for the medical personnel. And the last one is MedBase. This is a platform applying the orders for the doctors to select the proper time to work. So the main conclusion is that the most promising solutions are connected and based on the AI. So this is a typical software solution that can optimize the working in the hospital. And for example, for this meeting, there was a vice minister from the digital ministry and vice minister from the of the health. They told everyone that the most focus area is connected with the digitalization and optimize the workflow in the hospital, focusing on the patients, how we can help the patients to shorten the procedure and optimize the process of working for the doctors. And what I can see from our perspectives for the cooperation. So in the next edition, they plan to create an incubator. So this incubator can provide a solution for the startups like matchmaking with the hospitals, create pilot programs to implement the solution, support mentors to show how we can implement the solution in the hospital area, as well as we can see that the most important value for the hospitals is connected with the artificial intelligence and design new medical devices. For example, one of the solutions was connected with the ablation process, so that can accelerate the surgery from the 1 hour to few minutes. And what is interesting, they also looking for the cooperation to organize the medical conference in Krakow in the future. So let's start from my topic, my area. First of all, this is something personal for me because when I was young, I broken my hand and I need to put the plaster gypsum. What I can't swim, I can't take a bath, and it was very heavy. One plus of the situation was that my friends can write from my plaster cast and created some different pictures. So first of all, I would like to focus on the techniques that we can use in the modern attitude in the medtech to create personalized medical device. So the most popular three methods that we can scan the patients connected on the from the source of the 3D scanner and the structure of this device. So one of them is some temporary solution like time of flight scanning sensor. It is a very cheap solution. However, it is a very big range of the, for example, we can create the objects that more than 5 millimeters. Structural light-based techniques is connected with the solution created for the specific medical area. Also, I have this solution with me, and later I can show how we can create the 3D scan of different parts of our body, like limb or ankle, whatever. This is some portable solution, and we can implement it in the different areas. And the last one is the stationary 3D scanner. This is a very good solution. However, we can create the proper area to put the scanner and start scanning a patient. The second thing, what is most important in my research, is connected with the 3D printing techniques. So I can use the three different methods. The first is connected with the most basic option we can see, and we can buy very, very cheap 3D printer. It's focused on the fuse deposition modeling. This is the solution based on the filament and heated nozzle that we can put the material through the nozzle and put the material layer by layer, created 3D object. The second one is connected with using the laser as the source of sintering. So this is the method laser selecting sintering, that we have powder. The powder is put it on the working chamber, and we can use the laser to sinter the layer. And after the sintering this layer, we can put the next level of the powder, and we can continue process until we create the 3D object. The last one is connected with the big corporation, HP. They created the technology which is called multi-jet fusion. The solution is very similar to the typical printer, because we have also a powder that is connected, is necessary in the 3D printing. However, we also have an agent. This is something like ink in the typical printer, but this ink, which is called in 3D printing agent, this is some chemical substance that we can put on the powder, and the process is using the heat from the lamp. So we can use the temperature to create the layer. So when we created the layer, the next stage is to put the next level of the powder, and we also put the agent, we can heat, and we can do it until we can create the 3D object. So according to the history, it is the one thing what I noticed in the 2019. It is connected with the Gartner report, and what was very important from the typical application, it was applying the 3D scanners in the industry, create the place that we can produce components using the 3D printing methods. We can see some OEM production, what is typical in the automotive or another area, and create the solution that are industrial. So right now I would like to focus on the Polish solution that using the 3D printing techniques to create the medical devices. The first is Glaze Prosthetics. This is the company coming from the Krakow. They create the personalized amber limb prosthesis, and they use the HP multi-jet fusion technology to create these products. This is very important to design and manufacture the personalized product for the patients, and create the suitable solution for that. The second one is Fabionic. This is the company coming from the Poznań, and they create the hand prosthesis using the 3D printing. They use material which is similar to the silicone, that they create the hand that is very similar to our body, and they also use the 3D scanning process to create the solution that we can put on the lacking hand. The next one, this is the Proteo. This is company coming from the Łódź. They specialize in create the prosthesis limbs. They create a personalized production. What is more, they also have the reimbursement from the our government, because some patients can get money back from the government to buy this product. And the last one, this is a solution from our area, because this is the project from the Poznań University of Technology. It was done by Professor Górski, who was my reviewer, and they create the automated system that we can scan the patients in the proper way, design product. They focus on the orthosis and prosthesis, and manufacture for the, and they also focus on the FDM technology, because they want to create a very cheap solution that they could be available for the young patients. So we can start from my topic. So we can move to the 19th century, especially to the Crimean War, because in that time the Russian surgeon Nikolai Pirogov was invented the plaster cast. So it was the first application to use this product for the injured soldiers. So when we talk about the foreign injuries, we can notice that in every year in the European Union, 3 million patients are suffered from the forearm fractures injuries. The problem in Poland is about 250,000 people in every year. But the problem is focused on the two groups, especially for the elderly people over the 60 years old, as well as the children between 10 to 14 years old, due to the process of the bone growing. And what is interesting, we can notice that we have many fractures from the children due to the changing the lifestyle, because the children want to spend their time in the front of the computer playing online games, not football, basketball, like that. So we can see that they both are worse than they that the children, for example, 20 years ago. And what is curious from the perspective of the hospital, in every year we can apply about 800,000 plaster casts. So also the doctors spend approximately 1 hour to put one plaster cast. And from the patient perspective, we also wait for about 2 hours to fully cure the plaster cast. So we generate additional costs from the surgery blocks. We also need about 3 people during the putting the plaster cast, because one person from the medical staff need to stabilize bones in the proper position. The second need to put the hand in the proper way, and the third putting on the plaster cast. So it costs times, and it's time consuming for the medical staff. So my idea was to create our own startup to create the solution that we can solve a problem with the plaster cast and get free the doctors of their job. So I created the Mediprinting company, as well as I started my implementation PhD in mechanical engineering field to create the technological solution that we can support the medical area with that solution, as well as my co-founders was connected with the medical area. They are doctors in orthopedic specialization, and we can take 2 R&D projects almost for the 2 million zlotys to create the solution connected with the support forearm orthosis system. So when we see for the typical production process of the 3D printed orthosy, we can divide for the four steps. First of all, we need the patients with the problem with the forearm. So the first thing is to do the scan, and it depends on the solution that we can take for a scanning. So it takes from seconds to several minutes. The next step is to create a 3D model based on the scan. So it depends on the solution we can implement from the software, because we can use some algorithms to design the product. We can use also generative design methods, for example, in software like NTOF, Rhino, or design the product by own, for example, using the software like SolidWorks, Autodesk Inventor, or many of them. The next step is connected with the 3D printing process, and it depends of the access to the solution and the material what we can create the orthosis. So it takes several hours to few days, depending on the place that we can print the element. And the last one is final product, and we can use this orthosis for our hand. What is interesting in that attitude, we have a solution that it only supports the recovery process for the doctors, because we need to do something immediately. So the doctors put the plaster cast, because they have this stuff in the surgery block. So they put it on the hand. So that attitude what I showed is connected that we can put the orthosis for the next visit to the doctor, and we can replace the plaster cast for the 3D printed orthosis. So in my job, I noticed some gaps in that solution. That what is very important, that the hand is changing during the recovery process. So we need to regulate the adjustment to the orthosis to the hand. The next is how we can create the product, and we can determine the life cycle of this element. The next is connected that how we can meet requirements with the healthcare market, and how we can really help to medical staff to improve this process. So in many solutions, we see that in many cases, we add extra jobs for the medical staff, then shorten this job. So it is very crucial parameter that must be done in some project connected with the medical area. So I have created the research hypothesis. The first was connected on the how 3D scanning parameters impact for the orthosis design. So it is connected with the forearm position, the time, and what we can do after all with the 3D scan. The second is connected with the selected methods of the 3D printing and post-processing methods that we can create the complete solution. The next is connected with the aging of the components that we manufacture, because it is important how long we need to put the orthosis for our forearm. For example, when we put plaster cast, it depends of our age, and we can put the plaster cast for 2 weeks. But in some accidents, we also take plaster cast by 3 months. So it's very, very long time. So we need to prepare the solution that we can use in the different condition, like in water, outside, and I also quantified this project. What is important by 4 parameters. The first is weight of the product. The next is how quickly we can put this orthosis and who can do it. For example, that we can do it by one person, myself. And the next is connected with the safety factor. So how we can design the product that we can very, very light product, but with a very big safety factor. And the last one is connected with the regulation system that we can adapt the orthosis to our hand during the recovery process. So the project result, first of all, we developed the 3D scanner station that the whole procedure for the doctor and patients takes 2 minutes, because we can start from the putting the hand in the proper position. Next, we can reset bones in the proper way, and the next we can scan the patients to create a 3D model and data to design for our orthosis. This station is connected with the structure sensor 3D scanner, iPad, and rotating arm and tripod. And this is the result of the 3D scanning process. And our idea was to implement the 3D scanning process as a tool that we can select the proper size of the orthosis, not design, but we can use the 3D scanner to measure the places on the forearm, and from the database we can see what kind and size of orthosis we can put for the patients. So the next stage of my research was connected that we have do research for almost 200 people and measure the crucial parameters of the hand, like metacarpus, wrist, forearm, to create group sizes for the patients, and also design the regulation system. In the first version, we create 3 groups, but it wasn't enough to put every patient we can see. For example, we have data from the handball players, and because they have very big hands, so for them was a group 4, and also the group 1 is, for example, for the child above the 60 years old. And the main my research area focused on the 3D printing technology and the manufacturing process. So I focus on the two techniques connected with the powder bed production, and also I implement the post-processing methods to create a complete product, because it is necessary to put a proper toughness, proper color, and check how it works in the real condition. So first of all, I conducted the mechanical properties from the SLS technology. I focus on the PL12 material because it is biocompatible, and this is also well known in the production area as a good material to product and design some medical devices. And I check the different orientation in the working chamber to find the best option to produce the 3D printed orthosis. The next is connected with the HP NJF technology. It also uses the PL12 material due to the biocompatible properties. And also I check the different orientation to find the best way to produce the orthosis. And also I check the impact of the post-processing methods to the mechanical properties. The next one, it was connected with the roughness measurement. It depends of the post-processing methods. and its impact for what we can sense for our hand when we can put the 3D printed object to our body. And the last is connected with the hardness measurement. So it is crucial parameter that we can check. We can put something on the, for example, for the floor, and we can see the behavior, that it's crushed, brittle, something like that. And the next one is connected with the whole workflow connected with the post-processing methods. So the first, we have a machine that we can clean the 3D printed object from the unsintered powder. The next is to improve the surface of the 3D printed element. And the last one is connected with the dyeing process for the selected parts, as well as we can also use the chemical smoothing to improve the quality of the surface 3D printed element. And the next is connected with the behavior of the product during the 12 months, and it depends of the applied first of all for the 3D printing methods, and next one for the post-processing methods. And we can see that the methods connected with the chemical smoothing radically decrease the mechanical properties. Also, we can notice the same behavior in the young modulus. This is the very important fact, due to that we can create some mechanical analysis, for example, in ANSYS. This is very important data to apply the material model that we can implement in dataset in this software to do the strength analysis. And the last one is connected with the component and the elongation. So it depends how we can check the elongation of the element. The last one is connected with the color. So it is interesting what we can see after the 6 months, 12 months. So from my perspective and my research, the elements coming from the HP technology, they still the same color during the 12 months than the elements creating in the SLS technology. The next step is connected with some process of production and additive manufacturing capacity. So first of all, we can use two attitudes. The first is connected with the efficient packaging of the components, that we can put as many elements as we can. And the second is connected with the best mechanical properties to manufacture the best orthoses. So I compare the two sides of this solution, and we can create the very good properties orthoses, but they are 2 times expensive than in the typical putting in the production way. So as well as we can consume more powder when we put the orthoses in the production area. So from my perspective, it was important to create the mechanical test to create the data set about the worst mechanical properties. It was valuable for me because for this information, I have done the strength analysis, and I estimate the safety factor. So when we saw the result is connected that we can put the orthosis in the different orientation in the working chamber and create as many we can put in the working chamber. So according to the product application, the first is connected with the treating injuries. So we can design a product easy to apply, and we can adjust the regulation to the orthosis to the hand. The second is connected with the process of early rehabilitation, because we have only two mechanisms that we can open and close orthosis. So it is easy to start early rehabilitation after 2-3 weeks and start mobilize the hand. And for the patient perspective. The next one is connected with the rescue, and this is something that we can implement in the ambulance, sport clubs, and equipment for emergency services as a solution that we can protect patients before some injuries after all. And the last one is connected with that we can implement in Industry 4.0, that is connected with the monitoring. So first of all, we can monitor the potential swelling, monitor the hand. And the next step is, for example, to put some sensors to create the telemedicine support, to support orthopedist to monitor the hand and the progress in the rehabilitation. And I also compare the plaster cast with the 3D printed orthosis, and the 3D printed orthosis is about 20 times lighter than the plaster cast, and we create the same or higher stiffness than the plaster cast. And what we can see, the results for the engineers. So the first is connected that I create the proper workflow that we can use from the best mechanical properties. So we can apply an SLS technology with PL12 material and the dimension solution based on the cleaning, dyeing, and polishing. From the cost perspective, the best solution is to apply the HP technology with PL12 material and the whole workflow with the dimension. This is important that the lifetime of this project is 12 months. So after this time, we need to throw away this product, looking for the medical requirements from the medical healthcare. And also we need to check the product, for example, for 3 months. And the solution is good also for the certification process, because this is a data connected with the regulation for medical class 1. So the research what I have done was implemented for the register this orthosis for a medical device in the first class, and also estimate how long we can use this product on the patient's hand, as well as the project was financed from 3 different sources. So it was connected with the 2 R&D projects. One was from PARP, and the next was from the industrial PhD program. and scientific mini grant. And the history come back. In 19th century, the plaster cast was invented first time, and in 2022, the 3D printed orthosis was used for the Ukrainian soldiers. And right now, this is a good moment to replace the 19th century with this plaster cast to solution for 21st century. So this is important from the perspective that when we create the product, we also need to think about the next step, the next generation of the product. So what is important from the development of healthcare is to implement the digital twins, also implement the more solution connected with the generative AI, and how we can manage the life cycles of the product. I have done the articles with my team, and I show the solution connected with the implementing antibacterial coating for the to create the 3D printed orthosis, to check how we can create and produce the 3D printed orthosis in the best way, and also how aging and post-processing process influence for the 3D printed components in the medical device. In the future research, I would like to focus on the continue my job with the 3D scanning, 3D printing technology, also implement the sensors in the 3D printed object, and also optimize the design of the personalized devices and how we can implement the solution in exoskeletons. And also I have cooperated with the companies connected with the 3D printing area, 3D printing post-processing, as well as in organization supporting the healthcare system in Europe and in Poland. Thank you for the presentation. And also I can later, after my speech, I can show the products in the real.
Thank you for the presentation. It was very interesting and concise. And one thing I wonder if the business MediPrinting exists still, or
no, because I was suffered from my problems, and the company was done, and they stopped the production.
So probably it's the first thing we can wish you to restore the company, probably a different name, but still it's yours. And the talk is now open for discussion. If you want to ask a question.
I had questions. Maybe you question, but maybe you said about it. What about contraction of the material? Because this printing is made in SLS technology.
This is from HP.
Yeah. This is not SLS?
No, this is the HP multi-jet fusion, but the post-processing methods is the same.
Have you some SLS printings?
Yeah, this is one, but it is post-processing by
I see that
by chemical smoothing.
Chemical smoothing, I suppose something like
this is the probe from the SLS.
Yeah.
So this is the typical color after the sintering from the white powder.
Yeah, but when we use synthetic Lisa, there was problem with contraction of material. You should put the model in the correct position. It should be, turned 45 degrees from the vertical position. And it was a really serious problem. Sometimes we had different results.
So it depends on the packaging percent if the work
But tell me about this method. This is something, because it looks like SLS, but what is the difference in this technology?
The source of the sinter, the component, because in SLS we have a laser as a source to sinter the layer of the powder. In the HP technology, we have also a powder, but we put the agent. Agent is some chemical substance we can put on the powder, and we have a heating lamp, and we use the source from the heating lamp to create the layer.
Okay.
So from when we
something like combination between this SLS and this which are moved from the pool, glue with the line. Okay, and I suppose this technology of finishing, post-processing is associated with, acetone or something like this, because sometimes when
patented technology from the company, and I don't remember the.
But with plastic filament
that they use, but
with
also
acetone chamber, for example.
But acetone is good for ABS. It's
exactly.
It's not good for DLF. And they have a process that they are according to the medical standards. So after all, we have a biomedical product. Because it's according to the standard 10993, which is responsible for the biocompatibility. Yes.
Okay.
Thank you very much.
Next question, please.
Thank you for the nice presentation. I have a question about the processing, about the whole process. So my question is regarding because you have this 3D scanning, and usually if this 3D scanning is not so good, you have to perform, you have to improve this 3D model, and then you can import this 3D model into the CAD software. So did you use an additional software in order to improve the 3D scanner, or use it directly?
We completely changed the attitude to manufacture 3D printed orthoses, because the first step was to gather the data about the forearm and the size. So we have done the research for the 200 people to select the data. After all, we divided for the different groups. So from the different groups, we have data to design product. In the next step, we select the best 3D scans from each group, and based on this knowledge, we used software MSoft to create the best 3D scan of the forearm. After all, we put the 3D printed scan to the SolidWorks, and we designed the orthosis for this standard, for example, for the M size. And the next step that it was connected that we can also implement the Rhino solution. This is the software that we can create the generative design algorithm, and it was support to create faster the orthosis size, because it's very hard to create the personalized solution with the regulation system in the typical software. For example, we test the end topology solution because they have a module that we can design the 3D printed orthosis based on the forearm hand. But we can't control the adjustment orthosis to the hand, because this is very important for the first days to create a proper stiffness between the orthopedic supply and the forearm. This is also the reason why the doctors don't want to use the 3D printed orthosis immediately after the injury occurred.
Thank you for that. So, in your case, you have this 3D scanning, the model, and you directly imported this 3D scanning into SolidWorks. Yeah, you do the use.
Yeah, but we completely change the manner what we do with the product, because I couldn't notice about it, because after all, we have a 3D scanner. The 3D scanner scans the hand, and it measures some 3 points in metacarpus width and the forearm, the 3 crucial parameters. And we see the data, and it was created the algorithm that it's show us the size of the orthosis. And we have 3 types of orthosis, depending on the size. So we can create the orthosis and put in the box. Doctor scans the patients and see, for example, okay, for this patient, the M size is okay. So I can put the M size orthosis and put on the hand. So we can shorten the procedure that we have product immediately, and we can select the best size for the patient.
And I have an additional question about the aging test.
Yeah.
Because you showed that you performed this aging test, and then you showed that the time was 12 months. So it means that you waited 12 months in order to get the results, or did you simulate the conditions?
I have done the research in the accelerated chamber to simulate the 12 months, but the research lasts 1 month in this condition.
Another technical question, because to this specific model, I suppose you make design in some CAD designer. You said SolidWorks. SolidWorks. Design position should contact this element and this element.
Yes, because
then tell me it's an error that now it doesn't. It doesn't do this.
Yeah, but
because
it is important that we can create some providing systems that we can
why my question is I ask because maybe it's effect of contraction, or maybe it's effect of some mistake during design process. That's here is very almost perfectly, but not in this part. Why this?
Because maybe it's not for this set.
Okay.
Because I take that show the complete product and the half product that we can start create the finalized object. So they are different.
Okay, then I'm coming back to my first question.
No, it's okay, because it was some kind of our painting that we created a different thickness of the object. So in the middle we start from the 2.2 millimeters and to the 1.5 millimeters, because we want to create the effect that we can have stiffness part when we put the hand, and we have a ductible element that we can put for the hand to in the proper.
Yeah, but I understand that contraction problem isn't a problem in the technology.
It's solved by the mechanism to put this elements together.
Okay, thank you.
Thank you. One question from the audience and to the remote audience. Do you have questions?
Oraz.
Yes, please.
Regarding the materials, do you know, it's you're not using the transparent materials here because there's no need. But do you know the material that is very transparent for 3D printing or like almost like a glass?
Silicon.
Okay.
And I noticed that in the France is the company that creates on the silicon and is similar to the body. And the white budget technology, but I don't remember what kind of material we can implement. But during the specific of my research and my process, when we want to create something from the powder, we need to have a proper color of the powder. For example, we need to use the white, and also we need to select the proper laser for that case. And the next, for example, the next powder is black or gray, because it depends on the absorption energy. So when we want to create something transparent, we need to use a different solution than SLS or HPHGF.
Thank you. The personal question is, if I'm looking on something like that, I usually imagine things to put electrodes or even smart sensors on it. Is it possible that you consider to put some electronics?
This is the reason why I want to cooperate with Plexo company.
Okay.
Because they have sensors that they create the 2D sensors, and we can implement the product like that and measure the temperature and the strength.
Okay. That's definitely interesting that you can put even several electrodes on the internal surface here and use electrical signals, let's say, for controlling the manipulator or some robots or something like a man-machine interface. I think it's an ideal thing. And on the external surface, it's ideal to put, I don't know, markers for motion tracking or something like that. I think it could be useful. And the good thing is that it's personalized.
Yes, this is crucial, and I also see my mistake about the consumer, because I focus on the foral injuries, and this is the solution that we have something immediately. But when we can focus for the patient with the problem like neurological, the personalized solution is the best, because they need to the product by the whole life. So they can wait for the predicted element 1 week, 2 weeks, because they use the line. But when we put something, for example, for the forearm injury, the recovery time is, for example, 4 weeks. So we don't need the product for the 2 weeks, because we can deliver after 2 weeks for the injury. Okay.
That's true. I even thought about, let's say, gamers. Imagine that things like that would warn like gamer who fight or control some virtual reality cars, etc. I think it could be imagined like that.
I have contact with the people from the kickboxing, and we talked that it was some interesting case, because they fight, and after all they have some injury for the after the fight. So we can put their hands for the orthosis, and they are going to the hospital, and doctor's checks were going on, but we don't create some additional injuries or fractures, because they probably have fractured bones, but they don't feel it due to the adrenaline and something like that. But we can protect the hands before the repair injury, putting the hands in the orthosis.
And by the way, is this material safe for X-ray or MRI?
Yes. I don't. Yeah, it was in device that we can. This is the device from the Laserobaria company, from the Śląskie Wojtrzy, and they have a machine to accelerate the recovery process using the laser for the hand. And I put the hand with the orthosis and nothing changed. And also I test this product with the X-ray. We can only notice these links because these links are made from the skin. So, but from the doctor perspective, it's not important to see these links when we put the fracture bones.